there, lovely one. It's me, Helen the Great, and we're going to go through the questions that you've just done in the milestone quiz. So let's start with the first one. Now, as we can see, all of our variables are to the power of 1, so this must be a linear equation. So let's rearrange it, and minus 3r is equals to, you always have to be careful with questions that you see as easy, interpret as easy, because otherwise your brain sometimes turns off. Even now, as I'm talking and writing this down, I'm double checking the whole time that I've written down the right things. So that means r is going to be equal to 13 over 5. What happened to the negatives? Well, negative 13 divided by negative 5 is going to be positive 13 over 5. Ooh, this one's nice. Because we have a denominator, we need to have a common denominator. So let's start with that. Our lowest common denominator, well, we've got q and we've got 2q, so it must be 2q as our lowest common denominator. I'm going to change it to the lowest common denominator, and at the same time I'm going to drop the denominator. So pause and try it for yourself, and then carry on watching. So it's going to be 7 times by 2 plus 1 times by 2q is equals to, well, fortunately that stays the same, 5, 2 plus q minus 2 times by 2. So that's 14 plus 2q is equals to 10 plus 5q. Look, it's a linear equation, minus 4. So let's rearrange it. It's going to be 2q minus 5q is equals to 10 minus 4 is 6. So it's going to be 6 minus 14, and that is minus 3q is equals to minus 8. So q is equals to 8 over 3. Not too bad. Okay, let's change colors so we don't get muddled between this one and the next one. Over here we have a quadratic equation, and we know it's going to be quadratic because if we multiply it out, we'll get f squared minus 5f is equals to 0. So we don't want to multiply it out, we want to keep it just as it is, which means we can tell you that f is either going to be 0 or f minus 5 will be equal to 0, so therefore f is equals to 5. Not so bad. And now we can make space for the next one. Let's just scroll a little bit and go back to purple. I like purple. Now here we have a quadratic, which means we're going to get how many roots? 2. How do we know? Because it's t to the power of 2. Okay, there's no common factor, there's no difference of 2 squares, so let's factorize it as a trinomial. So t and t, why? Because t times t is t squared. Then let's do minus 3 and 1, why? Because 1 times minus 3 is minus 3. So now t times 1 is going to be t, and minus 3 times t is minus 3t. What are they when they're added together? Minus 2t. So therefore, our brackets are going to be t minus 3 and t plus 1. T minus 3 and t plus 1, what are they equal to? 0. So therefore, well, t minus 3 will equal 0, so t must be 3, or t must be negative 1. Not too bad. Ah, this is a nice quadratic. It's made to look a little difficult because the 1's over there. But as soon as you see anything, any variable to the power of 2, you know you're going to have to do some kind of factorizing. So let's bring over the 1, and now we have a difference of 2 squares. 4m minus 1 and 4m plus 1, they're equal to 0. So now let's make each bracket equal to 0. We'll do this the slow way. Why? Because we're going to get a fraction. Okay, we get rid of the 1 first so that it becomes plus 1, and that means m is 1 over 4. Or we have 4m plus 1 is equals to 0. So 4m is equals to negative 1. So m could be negative 1 over 4. So there are 2 answers. Also not so bad. Solve for k. 3 to the power of k plus 1 is equals to 27. Yes, I was a bit sneaky here and I snuck in an exponential equation. Why? Well, because equations are equations, and just because it didn't appear in the notes doesn't mean you won't get it in an equation test. But you know how to do this. If we want to solve an exponential equation, we need to make our bases the same. So if this is 3, 27 has to be 3, and we all know that 27 is actually 3 to the power of 3. So that means, and I love this part of exponential equations, we know that this side is equals to that side, because we're told by the equal sign. If this base has the same value as this base, well, that must mean that this exponent is equals to that exponent. In other words, k plus 1 is equals to 3. And some teachers talk about dropping the base. Suppose you could think of it like that. I just like thinking of it in a logical way. Okay, so k is equals to 2. Let's go back to blue. Now solve for k. 1 is equals to 7 to the power of k. Hopefully you saw this trick immediately. Anything to the power of 0 is going to be equal to 1. So therefore 7 to the power of 0 is equals to 7 to the power of k. So k must be 0. We're flying through these, which is good. I didn't want to run out of time or make you bored, even worse. Okay. Now we have a linear inequality. Remember, we're going to do it exactly the same way as we would do a linear equation, so no point in getting all worked up about this. I'm just multiplying out the brackets. And now I'm going to take the 5x to the other side, minus 5x. We haven't divided or multiplied by a negative number, so our inequality sign stays in the same direction. Now we've got minus 5 plus 9. That's going to be 4. So we have minus 12x is greater than or equal to 4. We want to get rid of the minus 12. It's multiplying x. So now we're going to divide both sides by negative 12. What does that do to our inequality sign? Yes, it swaps it around. Not so bad. That's the only thing that's different between an equation and an inequality. So there, I've simplified it. And lovely wavy lines. We're on the last 2, home stretch. Let's play with green. Another linear inequality. We're going to rearrange it. But first, let's multiply out the brackets. And that's greater than or equal to 4x minus 4 plus 1. Rearranging, so it's 3x minus 4x is greater than or equal to, that's going to be minus 3, then plus 2, so we've got minus x is greater than or equal to minus 1. We're going to divide both sides by negative 1, or I suppose we're going to multiply by both sides, depending on how you look at it, which means that the sign changes direction. We're doing well so far. Got the last question over here. Let's go back to purple again. It says solve for x. What will make you freak out a little is this n. Don't worry, we know how to work with it. Now, we need to get x on its own. So first we're going to get rid of the denominator by making both sides over a lowest common denominator of n. Oh, where did the 2 come from? I don't know. Of n. And then I'm actually going to drop the bases at the same time. Or not the bases, the denominator. In other words, I have an squared is equals to 2x plus 7. We want to get x by itself, so let's get rid of 7 by subtracting 7 from both sides. Of course, this just looks like we've moved 7 to the other side and changed what it's doing, not what it is. Now, 2 times x, we want to get rid of that. So we're going to divide both sides by 2, but once again, it looks like we're just moving it across to the other side. And there we go. Not that bad at all. It's the a and the n and the fraction, which will make you feel not great. Well, lovely one, we've come to the end. And I'm sorry to say goodbye, but I know I will see you soon. Until then, have a great time. Much love.